Today we are discussed about ultrasonic imaging devices. That is the various devices available for testing of NDT. One among that ultrasonic imaging devices. Here the types of ultrasonic imaging devices are classified into various types, which is depends on the display mode. That's why this is scan display method. There are three type of scanning display methods. One is AScan, second one B-scan, third one C-scan. AScan is nothing but this is amplitude modulation scan, which is depends on the amplitude of the intensity. This is called as amplitude modulation scan. Second one B-scan is nothing but brightness scan. That's why it is called as B-scan. Then third one is C-scan. Display. Now we are discussed about one by one. First one is A-scan. The A-scan, which is similar that already you know that the ultrasonic testing method, that is reflection mode method. Like that, this device is also like that reflection mode method. Here you can see the probe. We are using the probe is transmitting and receiving probe. That is a single device which can act as transmitting probe and receiving probe. This is very simplest method. It gives only one dimension informations. Already you know that, which are all discussed in the reflection mode method. This is, you can see only one dimension informations. Here scan is amplitude modulation. In this mode, the reflected echo are displayed as vertical spikes. This is vertical spikes along the horizontal baseline of the oscilloscopy, that is CRO. This is very similar like that the reflection mode of ultrasonic testing method. Now if the ultrasonic wave pass through the medium, that is material, the sound source to fall on the surface of the sample reflected back to receiving probe, you can see the input pulse or initial pulse. The intensity is very high. Similarly, if the materials have any defect inside the materials, means now the ultrasonic waves to fall on the defect and reflected back to the defect, it received by the receiving probe. You can see in addition that one peak, that is defect peak. If the materials have no defect inside the sample, means you will get the echo from the bottom of the pulse, that is back echo pulse. So these are the already discussed, which is very similar that the reflected method of ultrasonic testing. This is A-scan display. Here, which are all depends on the intensity of the peak, that is amplitude modulation of the peak. So this is A-scan. From this A-scan display, you can find the depth of the flaw. By measuring the time interval between the initial pulse, echo pulse and defect pulse. That is, you know that formula, that is depth D is equal to VT divided by 2. By this formula you can find the depth of the flaw. And what are the advantages of this method is the size and location of defect can be determined. So you can find the velocity of the ultrasonic waves if you know the thickness of the specimen. Then only you can find the velocity of the ultrasonic waves. Then another one advantages is the attenuation of sound in the material can be studied. You know attenuation? Attenuation means nothing but it is losses. Attenuation means losses. The loss of sound in the material can be studied. If you knowing the velocity of the sound materials, you can measure the thickness of the specimen. If you know the velocity means, then you can find thickness of the materials. So these are the some of the advantages of AScan. Second one, B scan. B scan or brightness mode scan. B scan or brightness mode scan. B scan or brightness mode scan. Here you can see the defect in two-dimensional image. You can see two-dimensional image. In B scan, the transducer is moved on the surface of the specimens. In this B scan method, you can move the transducer like this, the surface of the specimen in two dimension. The reflected echo from various points and displayed in the form of dots on the screen. Then the brightness and size of the dot depends on the intensity of reflected echo pulse. The size and intensity of the dot is reflection of echo pulse. Thus, the B scan provide exact image of internal structure. When compared to this A scan method, this is well in advance. You can see the size of the defect with the two-dimensional image and exact internal structure you can find by using this brightness scan, that is B scan display. Then what are the advantages of this B scan is the depth and shape of the defect can be determined, and in this method which gives the permanent record of the image of the defect. So you can find by using this method the permanent image can be determined. Disadvantages, it is cost wise very high when compared to A scan. Then the actual size of the defect not obtained in B scan. The depth and shape can be determined, but the actual size would not be able to find by using this B scan display. Then applications which is used in medical field, you can find the internal organs of the human bodies and so on. The third one is C scan display. In this method, the ultrasonic waves adjusted such that the ultrasonic pulse can be reached at a particular depth from the surface of the specimens. Here we are using one probe, and the ultrasonic probe connected to an XY platter. This is XY platter. It is moved over the surface of the specimens. This XY platter, here probe is moved in the XY platter surface of the sample in the form of zigzag fashions. Zigzag fashions, or which is closely placed parallel lines, or closely placed in parallel lines like that. This is top of the surface, which is look like that, the zigzag platter, XY platter. Now the probe, this is like that specimen. Now the probe is moved on the XY platter. If the materials gets any defect, you can see this is look like that, and you can see in the CRO screen the clear size of the image, and the intensity echo received from the section of the specimen recorded, and intensity is also recorded. The shading with the blank space corresponding to the defect regions. This one is defect regions, which is you can see in the CRO screen. In this method, you can only the position of the defect. You can analyze only the position of the defect, not determine depth of the defect. Not determine depth of the defect. You can see only the position of the defect. So what are the advantages of this method is, you can find the position of the defect with the cross-sectional area, and it is an automatic method. Now when switch is on means the probe is moved XY platter on the XY platter. This is an automatic method. Then what are the disadvantages of this method is, the depth of the defect information cannot be determined. This method would not be able to find the depth of the defect, and it involves high cost compared to other two types. When compared to B type and A type, its cost price is very high. Then advantages of ultrasonic flaw detectors. What are the advantages of these flaw detectors? The ultrasonic specimen is fast and reliable methods for non-destructive testing. That's why we are using this type of ultrasonic method for non-destructive testing. And it is more sensitive and effective than radiography using X-rays or gamma rays. When compared to X-rays, gamma rays, it is very sensitive methods. And location, nature and size of the defect can be accurately determined. From these methods, you can determine accurately in the defect area, location and nature of the size. And in this method, low cost and high speed operation when compared to other methods. This is a very low cost. That's why we are using this type of ultrasonic imaging method. And the defect at a deep distance from the surface of the metal can be located, and minute flaw can be detected. In this method, you can find very minute flaw. These are some of the advantages of ultrasonic flaw detectors. Once again, I tell you the AScan method. Here, the ultrasonic source to fall on the substance, that is surface of the samples, and reflected, that is the initial pulse you will get the left side of the CRO. Then if the materials don't get any defect means the sound waves to fall on the bottom of the surface reflected back to receiving probe, which will emit the back echo pulse. If the material gets any defect inside means you will get in addition that one peak, that is a defect peak. From this method you can find depth, and if you know the velocity means you can find thickness of the samples. If you know the thickness, you can find thickness of the sample, you can find the velocity of the ultrasonic waves also find, that is V equal to 2D by T. Then second one is the brightness scan. Here the image, you can find the two-dimensional images. Now you can move the probe in the two dimensions, you will get the intensity of the dots which will identify the defect. Then third one is C-scan method. This is we are using XY platter. The probe is over on the surface of the samples in the XY platter. You can find the top surface of the object is, this is like that, the position of the defect by the CRO. You can see this is the defect where the position is, where the defect is positioned in the samples also find.